So next is we are going to go for the next experiment, that is going to be a new project. So now we are going to see a FET characteristics. So we'll have it as FET char. That is the name what I am going to give. So browse in a D location. OK. So here in this case, create a blank project. So create a blank project there. Now it is going to be your OK. So once it is OK, you are going to get a blank this one there. Now we are going to start. So here place your part. So part is nothing but, now what is the part I want is J2N3819. So I have got the FET there. So now place the part. So I will be getting the FET. So N mode. So you have got the FET there. Once you get the FET, then next is your resistance. So resistance, you are going to take the resistance value. So place the resistance there. So I am going to take one resistance here. So that is going to be the resistance I am going to use here, N mode, and it is going to be there. Next is I can take a, so here in this case I can take either this resistance or that resistance, that's not a problem there. So here we can take it as this resistance itself. So resistance, your escape, your resistance is placed. Next is we need your voltage. So your VDC voltage, so VDC. So take this VDC voltage, place it here. Similarly, place your VGG voltage here, escape. So once you have placed your this one, next is to do the wiring part. So now components have been taken, so we can go for your wiring. So here we are going to connect it. So this drain is going to be connected to your resistance. Similarly, the other end of this resistance is going to be connected to your voltage power supply here, and this end is going to be connected here. Next is again take a wire here, so connect it like this. So this is very short, so it escape. So now you have come out. Again now take your wire, so next is, so this end you connected. This one connected to your gate terminal of your FET. So once you connected, escape. Next is you have to place the probe here. So to place the probe, you can type VCC. So then automatically a probe will come, press enter. A probe will be coming here. You can place the probe here, because the voltage which I want to measure is going to be your gate source voltage here, and again I will place one more here, that is your VDS. For that I am going to connect it there. Now press escape. So next is we are going to fix the values there. So this one we are going to have it as your voltage is going to be, click on this, double click it, you will be getting, so name it as your VGG, or you can have it as your VGS, because you are going to measure the voltage at that is going to be a VGG voltage only. This is your VGG voltage, a gate voltage, so we call it as a VGG voltage. Now this one we will take it as VGS. Okay. So this is across your gate source terminal. Now it is going to be across your drain source terminal. So we'll name it as VDS. VDS. And this voltages are VDD voltage. Okay. So now we have set all the voltages. Next is we have to do a ground connection. If ground is not been done, so 0 capsum. Okay. Place the ground here. So once you place it, press your escape, enter. So now your connections are over. What next we have to do is go for your simulation profile. PSpice, new simulation profile. For this it is your new simulation profile. I'll keep it as test. Create. So now a simulation window will open. So you can see here. So open it. Now you have to go for a DC sweep. Go to the analysis type here. Go to DC sweep. Because we are going to give your DC voltages. So a primary sweep. Now we want to go for transfer characteristics. So a primary sweep. Your primary sweep, we are going to give it as your VGG, input side. So VGG voltage, it is going to be 0. You know that your FET is your reverse bias there. So here in this case, it is going to be your -5, and this is going to be -0.5. Next is go for a secondary sweep. Your secondary sweep is nothing but when VGG is varying, I have to have my VDD voltage there. So VDD is going to be 0. Your fixed voltage is 0, 30, 15. Now OK. So we are going to apply it. OK. So after applying it, we are going to run the program. So if I run the program here, so I'll be getting a new simulation window there. So a new simulation window I have got. So now I should see what is my x-axis and what is my y-axis. So for x-axis, go to plot, axis settings. In axis settings, go to axis variable. So you'll get a list of axes there. In this I should select the axis variable there. So axis variable is going to be your VGS voltage there. So your VGS I am selecting it. OK. Next is your OK there. Next, that means that your x-axis your VGS and trace. Trace is going to be for your y-axis. Add trace. So here going to add trace, it is going to be versus your ID. So ID here, it is going to be your ID current. So ID versus your VGS. Now OK, you have got the output. So this is your ID current and this is going to be your VGS. So for 15 and 13, 0, 15 and 30 volts, you are going to get the output waveform, your drain characteristics there. And next once the transfer characteristics has been got, next we have to go for your drain characteristics. To go for a drain characteristics, close it, close this window, go to PSpice, edit simulation profile. So in your edit simulation profile, that is DC sweep is already there. So your primary sweep first you are going to see. Your primary sweep is going to be now your drain characteristics. So drain characteristics means outside. So VDD, it is going to be 0, 30, and the step size I am going to have it as 1. Next is your secondary sweep. So secondary sweep is going to be your VGG. So it is going to be 0, the negative voltage, so -5. So here is going to be -1. Okay. So once it is done, now what we have to do is we have to run the program there. So run it. Now you will be getting a new simulation window there. So in this new simulation window, open it. So when you open it, now I have to fix the x-axis there. To fix the x-axis, go to plot, axis settings, your axis variable, in your access variable, go to VDS. So we want VDS, your output. So OK. Then here OK. Next is go to trace, add trace. In this we want versus your ID current. So ID versus your VDS. So here OK, we have got the drain characteristics. So for different values of your drain current, your VDD voltage, we have got the drain characteristics. So this is about your transfer and drain characteristics of your JFET.